Algebra 2 students do the homework help video. Page 309, numbers 5 through 12, and 13, 15, and 17. Let's go ahead and jump right into this, please. Numbers 5, 6, 7, and 8. We're going to evaluate these given values into this piecewise function here. Okay? So let's start off evaluating f of negative 3. Now, I've got to decide whether I'm going to put negative 3 into this function here or this function here. Okay? So, as I look at my constraints, here I want all values less than negative 1. Let's put a number line up here so there's no confusion. Here's 0, 1, 2, 3, negative 1, negative 2, negative 3, negative 4. Now, negative 3 is to the left of negative 1. Negative 3 is less than negative 1. Negative 3 does not fit into this constraint. It fits into this constraint. So I'm going to use this function right here. So negative x squared, negative 2x. Everywhere there's an x, I'm going to put a negative 3. So negative sign first, then parentheses, negative 3. Then negative 2, negative 3. Negative 3 times negative 3 is positive 9, but I'm bringing down my negative sign, don't forget. Negative times a positive is negative 9. Negative 2, negative 3 is positive 6. So I get out a negative 3. So f of negative 3 is negative 3. Alright, let's take a look at number 6. Number 6, f of 0. Well, guys, here's negative. See, my main value, my critical value here on my constraints is negative 1. So I'm going to circle negative 1. Now 0 is to the right of negative 1. So I'm looking for the one that says x is greater than negative 1. I want all numbers greater than negative 1. 0 fits into this constraint right here. So I'm going to use this function right here, x plus 2. So where the x is, I'm going to substitute 0. And obviously 0 plus 2 is 2. Alright, moving on to number 7. F of negative 1. Well, this constraint here says all numbers less than negative 1. However, this constraint right here says all numbers greater than negative 1 or equal to negative 1. So this is the constraint that I want. So this is the function I will use. X plus 2. Alright. So where the x is, I will substitute negative 1. Negative 1 plus 2 is 1. The answer is 1. Alright, and last but not least, number 8, f of 3. Well, this constraint here says it wants all values less than negative 1. That's no good, but this constraint here says all values greater than negative 1, which would include 3. So we're going to use this function right here, x plus 2. I will substitute 3 into the parentheses. And obviously 3 plus 2 is 5. Okay? And so there is the answer, 5. These are pretty simple. Let's jump on to 8, 9, 10, 11, or 9, 10, 11, and 12. My critical value here is 1. Okay, here's my constraints. We're going to start off by evaluating g of 1. Okay, so we're putting 1 in for x. Now, this constraint says it wants all values less than 1, but also equal to 1. And this one's not equal to 1. So I don't want this one. I want this one. Okay? So I'm going to use this function right here. Alright, so negative 2x minus 1. Where the x is, I will substitute 1. Negative 2 times 1 is negative 2, negative 1. Negative 3 would be your answer. You owe me $2. You owe me $1 more. Negative 3. Alright, let's try negative 2. Well, this constraint says all values less than 1. Well, that would be negative 2. This constraint says all values greater than 1. Negative 2 is not greater than 1. So negative 2 fits this constraint. So I'm going to use this function right here. Negative 2x, negative 1. So where the x is, I'm going to substitute negative 2 because that's the value they give me right here. Negative 2 times negative 2 is negative or positive 4. And then bring down your negative 1. Well, your answer is going to be 3, obviously. 4 minus 1, 3. Alright, let's take a look at number 11. I'm going to substitute, or excuse me, I'm going to evaluate the function says all values less than 1. Well, 4 is not less than 1. This constraint says all values greater than 1. 4 is greater than 1. So I'm going to use this function right here. So negative x squared, positive 3x, negative 5. So negative first, then your parentheses, then 4, then positive 3, then your parentheses. And here we go. First you square your 4 and you get 16, but bring down your negative sign, so negative 16. Positive 3 times positive 4 is positive 12. Then bring down your negative 5. If you combine these, you will get a negative 9. Negative 9. Okay? And then last but not least, let's take a look at number 12 here. We're going to evaluate this piecewise function at 0. Now this constraint here says all values less than 1. Well, that works. 0 is less than 1. This constraint says all values greater than 1. That's not going to help us. So 0 fits into this constraint here, so I'm going to use this function right here. Negative 2x, negative 1. Where the x is, I will substitute 0 because that's the value that was given to me to substitute in. Negative 2 times 0 is 0, 0 minus 1, or 0 negative 1 is negative 1. And there's your answer. Alright, now let's jump on to 3 graphs. Okay, 3 graphs. Now, let's start off with the first piece to my puzzle. F of x equals x plus 5. Okay, now, notice my highest power is 1, so I know it's going to be linear. I have a linear graph. So my table of values only needs to hold 3 values. That's definitely sufficient. Now, look at your constraint, a negative 2. So I'll put a negative 2 first right here. And then it says all values less than negative 2. So getting smaller would be negative 3, negative 4. Now, is there an equal sign here? No. So am I really supposed to put negative 2 in? No. So don't forget to draw a circle and remind yourself we have a hole right there. Okay? Now we can do this quickly. Put a negative 2 in for x. Negative 2 plus 5, 3. Put a negative 3 in for x. Negative 3 positive 5 is 2. Now put a negative 4 in for x. Negative 4 positive 5 would be 1. So in your notes, I did it a little differently. In your notes, I had you go ahead and get the table of values all set up for both of these, but I'm going to go ahead and just do the one now and go ahead and graph it because there's not a lot of space right here, and then we'll move on to the next one. So negative 2, 3, put a hole there, and then negative 3, 2, and then negative 4, 1. Now, always put your pencil on the first ordered pair and draw toward the other points, okay? And there we go. Now, let's go ahead and graph our next piece. Our next piece is f of x equals x squared, positive 2x, positive 3. This is a quadratic. We know that because I have a squared for a variable. So my highest power is a 2. So I know when I graph this, I'm going to get a parabola or part of a parabola or something like that. So it's wise to put a table of values with 5 ordered pairs. Am I going to make that mandatory? I probably will on a test or a quiz, okay? It's important to do that. Now, notice your constraint right here. Here's your quadratic function. Here's your constraint. Notice your constraint starts at negative 2. And then it goes greater, all values greater than negative 2. So getting large would be negative 1, then 0, then 1, then 2. So students, only thing we have left to do is hard work. Let's get after it, okay? Substitute negative 2 in for x. Oh, by the way, notice I did not circle this and put hole. That's because I have an equal sign here. X is equal to negative 2. So I'm allowed to put negative 2 here into my table of values. Okay, negative 2 squared would be a positive 4. 2 times negative 2 is a negative 4. Positive 3. Combine that and you will get a 3. Alright, let's go ahead and did not mean to do that at all, that's for sure. Let's move that eraser down a notch. Alright, let's go ahead now and substitute negative 1 in for x. So parentheses negative 1. And then 2 parentheses negative 1. Negative 1 1 times negative 1 is 1. 2 times negative 1 is negative 2, and then positive 3. And if you combine those numbers, you will get a 2. Alright, next let's put 0 in for x. And so here we go. Put a 0 for x, because that's my next x value right here. 0 squared is 0. 2 times 0 is 0. 0 plus 0 plus 3 is 0. Positive 0 positive 3 is 3. Alright, let's now substitute 1 in for x. 1 times 1 is 1. 2 times 1 is 2. And then positive 3, which gives you a 6. And then last but not least, we're going to substitute 2 in for x. And here we go. 2 times 2 is 4. 2 times 2 is 4. Positive 3. That would give you 11 if you combine those numbers. So, let's quickly graph this. We have negative 2. Oh, look at this now. I've been waiting for this to happen. We have a hole right here at negative 2, 3. But now we fill the hole in with this part right here, negative 2, 3. So if they overlap, then it's okay to go ahead and color this in, because the graph that does exist at negative 2 overlaps the hole right here, so that's fine. And then negative 1, 2, and then 0, 3, and then 1, 6, and then 2, 7, 8, 9, 10, 11. Now remember, start at this ordered pair here and draw toward the other ordered pairs, alright? And there we go. There is our piecewise graph. 1 down and 2 more to go. Alright, number 15. Now, here's the first piece to my puzzle. H of x equals 1/4 x minus 2, or negative 2. Now, we do have a linear graph. My power here is 1, so I only need a table of values that holds 3 ordered pairs. That's definitely sufficient. Now go to your constraint, go to your constraint. My critical value here is 4, so I'll put a 4 here, and then it says all values less than 4. So we'll go 3 and then 2. Now, I'm not going to circle this and put a hole here because it is equal to. Alright, now let's make our substitution, and we're doing pretty good. If you're not good with fractions, use your calculator, please, okay? Alright, 1/4. 1/4 times 4 is 1. 1 minus 2 is negative 1. Now put a 3 in for x. 1/4 times 3 is 3/4. And 3/4 and a negative 2 is a negative 1 and 1/4. Use your calculator if you need to. Next we'll substitute 2 in for x. 1/4 times 2 is 1/2. 1/2 negative 2 is negative 1 and 1/2. So here we go. Over 4, down negative 1. Over 3, down 1, and no, did I make a mistake here? Let's see. Down 1 and a 4th. No, that's right. Sorry, students, I apologize. Over 3, down 1 and a 4th. About right here. And then my next ordered pair, over 2 and down 1.5. Now remember, you put your point on the first ordered pair and draw it away. Draw it toward the other points like that. There we go. Okay, that piece is done. Now let's jump to the next piece, which is h of x equals x squared negative x negative 13. Now, this is a quadratic function. We see our highest power is 2 for a variable, so I know it's going to be a quadratic. So I'm going to write a table of values that holds 5 ordered pairs. Okay? And here we go. Here's my constraint. My critical value is 4. Now look, there's no equal sign here. You're not supposed to put 4 in. So I've got to circle it and remind myself I have a hole in the graph. Now, I want all values greater than 4, so next will be 5, then 6, then 7, and then 8. Okay, so here we go. Let's substitute 4 in. And guys, I'm not being lazy or trying to rush through this, but there has to come a time where you understand that we can do a lot of this quickly, okay? Watch. We're putting a 4 in for x. We'll do this in your head. 4 squared is 16. Now if I put a 4 in for x, I have a negative sign here, so it's a negative 4, and then a negative 13. So that gives me a negative 1, I believe. Yes, negative 1. Now let's put 5 in for x, okay? Put a 5 in for x. 5 squared is 25. And then a negative sign here, so negative 5, negative 13. Alright, that will give you a 7. Alright, now let's move on and put 6 in for x. So 6 squared is 36. And then a negative sign, so negative 6, and then negative 13. That would give you 17. 17. Okay. Now let's substitute 7 in for x. 7 squared is 49. And they have a negative sign here, so negative 7, negative 13. And then next we're going to substitute 8 in for x. 8 squared is 64. Negative 8, negative 13. That'll give us 43. Now obviously I'm not going to plot these last two. That's kind of crazy, but it still helps give me an idea of what we're looking at. So the hole in the graph is negative is 4, negative 1. So here it is. Look, it falls right on top of this. So don't put the hole there. The hole's gone. The hole is filled in by this overlapping graph. So I'll put a point there. And then 5, 7. So 5 up to 7. And then 6, 17. So 6. And way up here somewhere, 17. So even though it looks like a straight line, we do know it's going to curve somewhat like this. Because it's a parabola, it's a quadratic. And it's going to head on up, which I know this is not a very good graph, but still you get the idea. And there it is, guys. That's it. Okay. So really not too difficult. Alright. Alright, let's move on. Sorry about that. There we go. Let's move on. Now, alright, last one. Let's see how we do here, okay? Let's write our first piece of the function, of the piecewise function, and our first piece is this right here. Okay, and my constraint is this. Now I know it's a quadratic because I have a power of 2 and that's my highest power. So I know it's going to be it'll be very intelligent to go ahead and put 5 values in my table of values. Now like the last problem, I didn't use all 5 values, okay? And that happens sometimes, but it's still safe to put 5 ordered pairs. So my constraint is right here. My critical value is 3, and I want all values less than 3. So 2, then 1, then 0, then negative 1. Also, this is going to be a hole in the graph. Okay? A hole in the graph. So here we go. I'm going to substitute 3 in. 3 squared is 9. Substitute 3 here. 4 times positive 3 is positive 12. Negative 20. Alright, that's going to give me a 1. A positive 1. Alright, let's now substitute 2 in for x. 2 squared is 4. Put a positive 2 here. Positive 4, positive 2 is positive 8. Negative 20. That gives me a negative 8. Alright. Let's substitute 1 in for x now. 1 times 1 is 1. Now be careful here. 4 times 1 is 4. Negative 20. That gives me a negative 15. Okay. Now, let's try 0 next. 0 squared is 0. 4 times 0 is 0. Negative 20. And then lastly, we're going to substitute negative 1 in for x. Put a negative 1 here. Negative 1 squared So here we go. I can graph this, and my y values, I'm going to slide this over a little. My y value should be down to a negative 23, and maybe I'll try to get all of these on this time, unlike the last time. Let's see what I can do here. Let's go like this, 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 and I need my y values to go up to negative 23. That's quite a bit. I'm not sure if I can do that. I think we'll run everything maybe in, let me take a look here. Yeah, we'll run everything on the y-axis and the x. Let's keep the x-axis increments of 1. Okay, we can do that. There's nothing wrong with that. You can do that. And let's make the y-axis increments of 2. That's unorthodox, but it's not inaccurate. You can do that. So I'm going to use negative increments of negative 2 on my y-axis, and increments of 1. I'm going to use increments of 2 on my y-axis, and increments of 1 on my x-axis, okay? And here we go. So my first order pair is 3, 1, and then 2, negative 8. So 3, 1, and then 2. Did I do that the wrong direction? Oh, wonderful. Alright, we know what we're going to do. We're going to do this, and we're going to erase that. We're going to do this, this, and this. And we're back in business, alright? Alright, let's see if we can do this a little better this time without making mistakes. 3, 1 is the hole in the graph, so over 3. And remember, it's up. These are increments of 2, so don't go up to here, go right to here. So over 3, up 1. Then we have 2, negative 8. So over 2, then down negative 8, 2, 4, 6, 8. I know it's going to be a little confusing with this axis being increments of 1 and this axis being increments of 2, but we can do this. Okay, next is 1, negative 15. So I go over 1, then negative 15, 2, 4, 6, 8, 10, 12, 14, 15, negative 15 right there. Alright, next would be 0, negative 20. So 0, and then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then next would be negative 1, negative 23. So negative 1, negative 20, 22, 23. So about right here. Alright. Now you start here, and it looks like to me it's supposed to have maybe somewhat of a curve in it somewhere. Something somewhat like this. Now, do not continue it like this. Be careful, okay? If you look back at your graph, you can see the numbers are not getting bigger, they're getting smaller. Okay? So it is true that eventually this graph's going to start curving back up a little bit somewhere. So I put a little curve to it, okay? And that's why it's so helpful. Students, listen. That's why it's so helpful to know what kind of graph you're dealing with. That's why I've taught you to notice, is it a quadratic? Is it linear? Okay? Now, last one here. Last piece. Was it g of x or f of x? I forget. F of x. Alright, so we have f of x equals negative x plus 4. Now that's a linear graph. We have a power of 1. Okay, a linear graph, so my table of values only needs to be 3 ordered pairs. Alright, my critical value is 3, and I want all values greater than 3. So 4 and 5. Boy, it's going to be fast. Put a 3 in for x, there's a negative sign here, so negative 3 plus 4 is 1. Put a 4 in for x, put a 4 in for x, there's a negative sign, so negative 4 plus 4 is 0. Put a 5 in for x, there's a negative sign here, so negative 5 plus 4 is negative 1. So my first order pair is 3, 1, alright? So over 3, up 1, so now that point is closed. So over 5, and then of course, if I went to here, that's negative 2. We're in increments of 2. So over 5 and down to here. Always start where your first point was, which is right here, and draw the line. And that's it, students. Wow. This is really, if you follow the steps I've given you, it's not that difficult, okay? Just make sure that you do that, and you'll be fine. I hope this video has been a help to you. If you have any questions, don't hesitate to call or email.